Hello Internet. Today we have this EVGA 3090 in for repair. I don't know exactly what's wrong with it, but I know for a fact that it had never been opened before and it had never been refurbished. In any case, the purpose of this video is not so much to focus on the repair, but to focus on the disassembly and servicing this card. I don't get a lot of these, so I figured it's an opportunity to take this thing apart, show you how it's done, and especially given the fact that this is a 3090, this is still a very powerful GPU, and it's going to be so for a very, very long time. And didn't want to miss the opportunity to show you how to properly take this thing apart without causing any kind of damage, especially breaking or creating solder joint problems or micro cracks under the GPU or under the memory chips, which is often the case when somebody's taking a GPU apart without knowing what they're doing. So, EVGAs are kind of annoying. They have these nuts here that we need to undo. So, arm yourselves with some kind of a screwdriver that fits inside of the screw hole. Does not feel loose. It feels like it's in there, and it's, so that it does not slip. And then you're gonna need some tweezers to hold the nut here, for example. See, we'll remove the nut, and we remove the screw. And so the nut that's here can be held by the finger, and that just comes off like that. And this one here as well. The magnetizing your screwdriver helps. There's another one with the nut here. There we go, almost. There it is. And then the rest of them are without the nuts. But they're all the same. And one is hiding behind a sticker here. So there it is. There it is. That one's out. This one's going to be out in just a second. There we go. Here we go. This one here. And before we continue ripping off the back plate, let's remove the leaf spring or tension plate, whatever you want to call this. Do not undo one screw at a time and then another and then another and another. Instead, do maybe like 1.5 turn on one, 1.5, 2 on the other, and go in a cross pattern. Then maybe 1.5 here, 1.5 here, and then start it over here, maybe 1.5. That one's already snapped. So if this one have already opened up, then don't go here or here. Instead, go back to the one that's right across from it. See right there. So now they're both relieved. So now you can just finish one or the other. It doesn't matter at this point. Right there. And there we go. So essentially what we were trying to accomplish here is to relieve the pressure as evenly as possible. We do not want any kind of flexing going on, any kind of force tension on either of the corners. That's very critical when you take these things apart. And that's the reason why, if you fail to do so, a lot of times you end up creating crack solder joints under the core or under the memory chip, and then things just break. So let's remove the back. And the back, you do not want to force this, but what you do want to do is to maybe pull a little bit here and a little bit there and just kind of wiggle it left and right like this. And just continue on gently, and it'll eventually break away. Maybe apply a little bit more force. But you do not want to bend this because it is not easy to get this thing flat. And if you bend this, you're going to have issues cooling the memory chips on the back because they will not be able to contact the board properly. So slowly, surely wiggle this out. And as you can see, the pads got damaged. So we're going to be replacing these pads. I could show you a trick how to reuse old pads, but maybe in another video I will do that. But for now, I don't want to reuse these pads. They are probably old enough anyway. And there's no way I can reuse them. That's one way you know that the pads are old, is when they're kind of embedded themselves into the chip. So I'm taking a razor blade and I'm scraping them off like this. Carefully. Don't worry about the capacitors that are on the side. They are sitting just below the surface of the memory chip, so you can safely scrape away all that thermal paste. But keep the blade on the chip. Do not let the blade slide off the chip. Always do it on an angle. Don't just go like this, parallel or right across the chip. Just kind of do it on an angle, so that way you have a little bit of a room to catch yourself before the blade goes off the chip. And if there's any residue on the backplate, obviously remove that exact same way. And you can take some alcohol and some cotton ball to wipe off the residue, so that the backplate is nice and clean and ready to receive a new set of pads. Now for the memory chips, sometimes you put in fresh pads and they don't seem to perform, and the reason for that is because the lack of you could say connection between the two surfaces almost on a molecular level. Not really true, but the thing is, these memory chips, they are not smooth like glass. They're almost like porous to some degree. They have a very rough surface. And so in order for temperatures to transfer from the chip to the pad, from the pad to the back plate, the contact has to be good. And if the surface is rough, the contact isn't very good. So gotta clean those memory chips, make sure that they're nice and clean, that the old thermal pad is removed from all those little tiny cracks as much as possible. You could use electronic contact cleaner. That'll help. I don't really use it. I think alcohol is doing just fine. So, but this one will do a little better. Yeah, as a matter of fact, it does. It does do a little better. I would say noticeably better, but it's not a requirement for you to invest any more money into this process. So alcohol does just fine. Whatever. This is the most critical part. Is we need some kind of tweezers. Is what I like to use, and I use these tweezers. They usually come with almost everything nowadays, and I like them because they're curved, because it allows me to access this latch here. Though you could probably do it with pretty much anything, even with the straight ones. So here's how you do it. So you get that. You can squeeze it from the top and just kind of pull it, but that's a little bit tricky. It's a lot easier to just go under the latch and just do this. And now we have disconnected the LEDs. And in here, same thing. We're just going to pry. We can push here and then pry, but it doesn't matter. We can just pry it out like this, like this, like this, a little bit. See, we can't even get this off all the way. And the reason for that is because that wire is actually going under the heatsink, preventing us from lifting this whole thing up. And that's normal. That's how EVGA assembles their cards. So the issue now here is that the two are still sandwiched together, and they are rock hard because of the thermal paste is dry, the party is dry, and the pads are dry, and everything's kind of dry, and it does not want to come apart. So how do we do this? How do we take this thing apart? Probably the easiest way to do this and the safest way would be to get some 91% alcohol or whatever, just pour it down there. It'll dissolve it, it'll soften it up, and then things will just kind of come apart. And then you can just use that same alcohol to kind of rinse everything off and blow it from under the chips and everything, so everything's nice and clean. But I mean, that's kind of overkill. I never done this before. It sounds stupid, but trust me, it's gonna work. So instead, what I'm going to do is, you do not want to pry in any of one place. So you want to pry in as many places as possible, and you do not want to pry like this, so that the ends of your whatever tool that you're using are pushing against the board. Instead, you want to kind of push the heatsink away from the board like this. And you want to find a place where you can actually pry without worrying about damaging anything, such as this hole here, this capacitor. There's a perfect spot. This coil here is also a perfect spot. But the thing is, all of the stickiness between the two plates, the board and the heatsink, are actually focused in this general area. So if I were to pry here, you would see that the board will flex, but I don't want that. I mean, there's a certain amount of flex that you can do, but I want as little flex as possible, and I want to be within that area. And that area is basically, the ends of the PCI Express slot. So we just kind of want to be here somewhere. So what I want to do is maybe I want to pry here, and then maybe I want to pry like over here somewhere. So you can see that where I stick my tool. And I'm just applying tension, and I'm holding it there. And I'm holding it there. And while I hold, you would think nothing happens, but actually there's a very slow separation happens between the thermal pads and the core and the thermal paste and the thermal potty. The slow separation does take place, so this will take a few seconds. Don't force it, just let it go. Let it do its thing. You don't want to force it. Just hold. You can increase the pressure a little bit at a time, and eventually you can kind of see it slowly starts to break away. That's what you want to see. You want to do it slow, and you want to be patient. Just wiggle it a little bit. There's a lot of pad. There's a lot less sticky stuff that's at the front of the card. That's why it comes off the easiest. A lot of that is still on the back because there's more memory chips on the back there. So it would seem a bit confusing at first why you would think that it's probably twisting so much that it has a gap here but not there. In reality, it's not true. It's just that there's a lot more pads on the back. So once you can see this, you can kind of work on these connectors. Almost. Maybe we can use this capacitor here now. You can use your fingers to help it spread like this, see? Slowly. So we finally have access to the connectors. Get those out of the way like this. And there you go. See all that pad, and then the pads on the back, they were the ones that were preventing the back of the GPU from separating properly or easily. And there we have it. So all of this is going to be removed. Razor blade. You're going to do 2.5 millimeter here, 1 millimeter, 2 millimeter, 1 millimeter, 2.5 millimeter. So that's how you do it. So we're going to get rid of this, and we're going to clean this area here. So we're going to start with, if you haven't damaged the pad for the driver MOSFETs, then you can definitely reuse it. If you have a tool like this, like a dental pick, then you can slide it under and just gonna gently and slowly lift away the pad. And I'm not gonna bother, though 99.9% that pad is perfectly fine, even considering the age of the card. Even if it was a 3080, that pad would still be okay. Even if it was a 3070, that pad would still be okay. EVGA uses good pads, and this area of the driver MOSFETs, it generally does not get very hot anyway, so it does not need any kind of excessive cooling like the memory does, for example. So then now, we'll get that out of the way. We use the same technique with the razor blade to scrape off the pad from the memory chips. Again, we're doing it on an angle, like so. And just slowly making our way out with these chips. Be careful not to slide off the chip so that you do not accidentally damage any of the components around them. And this X-Acto knife blade here works really well. I don't know what size the blade is. Let me see. Maybe I can measure it for you so you can get one if you want. Looks like a 12.75 millimeter wide. I don't know what that is. So it's like a 1/2 inch, yeah. So it's a 1/2 inch blade. I hate inches. And you could probably get that on the internet somewhere. And so it works really well. So you do not want to push on the board very hard. You do not want to flex the board. You do not want to bend the board. That's the key points here. Any kind of bending or any kind of flexing can potentially create an invisible crack solder joint under the core. So then this here can be cleaned, just can be scraped away with anything pretty much. A lot of times this thermal putty is rock hard, so I would just take that same razor blade, just kind of scrape it off like so. And do the same thing here. See, this one is all crumbly. Like that. We can carefully pick off the edges of the thermal paste around the core, or it'd be safer if we were to use some kind of a petrol-based adhesive remover, such as this one here. You can see the part number on the top, the MMDS number. That stuff works really well. Alcohol is not going to dissolve this. A drop of kerosene will. That's petroleum based. So then do not hit the board. Do not apply any kind of flexing to it, or minimize it as much as possible. So then we're going to wipe off the chips. I will wipe them off again with some alcohol to remove whatever may be stuck in the those little tiny micro cracks and crevices on these chips. Like I said earlier, they're not perfectly flat. They are a little bit rough, like a bumpy type of texture. So, and we'll get back to that. So now that we have this done, we can use a toothbrush, but it has to be like really hard. So not just any brush, like a regular toothbrush, probably not gonna work. And you don't really have to do this. It's just something I like to do. I like to clean everything as good as I can. So I'm just gonna brush these things out. And all I want is to remove whatever residual layers of thermal pads that were here, and then some off of the coils, like this. Yeah, that probably looks good enough. Then I can finish this off with alcohol to make the coils look nice. Now there's a lot of powder now in here after all that brushing, so we can just suck it out with a vacuum if you have one. A vacuum with like a brush attachment would do it really good. Alright, so if you have this electric contact cleaner, you can clean the core with it. It will work. As a matter of fact, let me see how well it works on that EVGA factory stuff. Yeah, cleans it right off. That's a little bit messy. That's why I don't really like this process. You can see here. I mean, it gets most of it out relatively quick, but I don't like this. I like these pads. They are a lot less messy. They absorb more, they spread less, and overall just gives me more joy. Just gonna let this thing eat its way through. This thing is so good. It's even safe for your skin. You know how some people have dry skin stuff, and you know, I suffered that a lot at my last job, and so I finally narrowed down that it was the pads that were killing me. So I just experimented with all sorts of pads, and I finally landed on these, and these work really well. So the same pad can be used to clean the memory chips, like so. And this stuff, this pad, it dissolves all of that material very well, and all that thermal paste, it just dissolves it really well. So, and it evaporates clean. So as a matter of fact, let me blow it out. See, perfect. Nothing left. I'll just wipe off any of the residue around the capacitors, around the core, with some alcohol and the Q-tip. Alright, there we go. So now, this is going to be the part where I start the troubleshooting, and then we'll get back to the assembly, repad, repaste, all that good stuff. So if you're into that, scroll forward. Otherwise, stick around. We're going to try to troubleshoot this card. Alright, so what do we have here? We have who knows what. Let's turn on the meter view for your convenience. There's our meter, and the memory card cover is open, whatever that means. Do we have a short on 1.8? No, we do not. Very good. No short on memory, no short on PEX. 3.3 is good. 12 volt here is good. It beeped, so that's good. That's a 5 volt. Reading nothing. Very good. 5 here, 5 there, 12 here. Nothing. 12 here. Nothing. 12 here. Short. Okay. So the fuse is blown. We have a short on 12 in here. We have a blown MOSFET. Most likely somewhere in this area here. Very common problem with an EVGA. Of all sorts of 30s here, 3080s, 3090s, 3090, not the 3090 Ti though. And the reason for that is because these cheap driver MOSFETs are there. So let's whip out the thermal camera from our holster, and let's give this thing, we're going to start from 1 volt. And we're going to start injecting after the fuse, because the fuse is blown. Injecting anything before the fuse is pointless. We need to inject after the fuse. Start looking around until we find something. In some rare cases, in very rare cases, one of the capacitors here could be shorted. And when that happens, it's going to be very difficult to detect. You just have to do it long enough for the capacitor to warm up until you see it on the thermal camera. So a thermal camera is an absolute must when it comes to repairing pretty much anything nowadays, or anything for that matter, including your life. So I look at the two at a time so I can compare one to another. This is the guy. This is the guy. If anybody out there, the repair techs, the schematic diagram level component super mega duper repair guys that really know ins and outs of these cards, please tell me and tell the rest of the world why this particular MOSFET blows on these cards almost all the time. Sometimes you get one here, but a lot of times it's this guy. Almost always. And I highly doubt that the problem is the MOSFET or the controller. I think there's something wrong with the circuit. There's something got to be wrong with that circuit. And just like with the Gigabyte, there's a problem with the capacitor that's soldered where it's not supposed to be. And as a result, one phase is working too hard, and then eventually it just burns out and it welds itself to the board, and even the fuse the fuse just barely saves it. A lot of times the damage is just too great, requiring you to Dremel the MOSFET out of the board. So, but regardless, we're going to be focusing on this thing today. Today is not a gigabyte day, so I'm going to put that there. And I will use the Black Horse flux. I'm liking it more and more. This is still the first batch, the original one that I got. It could be an issue sometimes doing, like if when you're ironing the edges of the driver MOSFET or small chip like this. In my last video, you've seen that I missed the two pins on the right side of the chip. It was shorted. I had to go over them again. And the reason why I missed them is because when you're using this, it's kind of foaming, and it kind of, you know, limits your visibility of what you're actually doing. So foaming is kind of a problem. You could potentially miss something, the area that you were ironing, and you know, that could have been a disastrous outcome if I hadn't noticed it. But I did notice it, so nobody died. Not today. So let's turn off the that thing. But other than that, another reason why I want to use this particular flux here is because it's so easy to clean. I mean, it's like the easiest to clean flux ever. Let me go ahead and brush away. There's a little bit more thermal residue from the pads there. I don't want that there. It's just don't want any dirt. Okay, so let's apply this. Apply this around here. Yeah, but otherwise, I absolutely like this flux. It's great for general soldering. You know, like MOSFETs, fuses, all kinds of stuff. It's really good. It smells super. I absolutely love the way it smells. And the way it cleans is just amazing. And it does not turn rock hard like the Northridge Fix flux does. You've seen, I don't know if you have or not, how it turns almost rock solid, almost into, I don't know, like sugar, like burnt sugar. Like it turns rock hard. It cleans easy, but this stuff cleans way easier. So yeah, whatever this thing is made of, it's way better. So in any case, so we're gonna heat this thing up. I'm gonna replace that. We're gonna replace the fuse, obviously. I don't have to wait for the board to warm up completely for replacing the fuse. So we're just gonna force it. Just gonna take a big soldering tip and just kind of force it if we can. Yeah, a little bit of hot air would definitely help. Let's see if we can throw in some hot air here. See, another thing I don't like about the flux is that whatever's in there, you see all that splatter? That's because of the additive in there, glycerin or whatever. I don't know what it is, but it was that thing that I managed to separate most of it out. So he said he was reducing it or something. So it's not that it's a problem or anything. It's just, you know, it just gets everywhere. And I'm kind of a perfectionist. I like things super clean, as good as I can. Probably a habit from my last job, in case anybody cares. I used to work in sterile processing, and where getting all the surgical instruments super clean and sterile and everything. A lot of small things. You have to be very detailed in what you're doing. You know, it's one of those jobs where you pick up certain skill. I'm a good dishwasher too, so that kind of one of those things. One of the things you learn at that job is you learn how to clean dishes. And I tell you, I clean dishes better than my mom. She never rinses enough. But don't tell her I said that, or she will never cook another meal for me. And I'll starve to death. Whatever, who cares? She stops cooking, I'll just go get married. Alright, so let's solder this guy. Hopefully we can do that without needing to add more flux. That looks a little crooked. I guess we can add more flux. Let's see. There we go. Does that look good? Yeah, that looks good, I think. Alright. And even cleaning this stuff off the board while the board is still warm is easy. I mean, look at this. You cannot clean the board this good while just after the soldering job is done with North 36 flux. You can't. With this one, you can. You don't even have to clean the board with alcohol. You can just wipe this off and it already looks really good. Look at this. See? But I don't like that hazy look, so I'm just gonna wipe it off completely so it looks super nice, super new, you know, as good as it can possibly be. You know, it's just my my thing. And there we go. Better than the factory. So let's move on over to that MOSFET. So we probably want to cover the capacitors on both sides so they don't blow into our face. And we're going to start heating up the area. I'm going to start heating up the area so that we can remove this MOSFET with as little blood as possible. I don't know how other people, of all the people that I watched, hardly anyone ever uses preheater. I cannot remove a driver MOSFET or any chip off the board without using the preheater, or at least heating it up for a good amount of time. So for me, a quick fix is almost never possible unless it's like a resistor or something. When there's a MOSFET or replacing a memory chip, without the preheater, no way. So we're going to bring in a second hot air here to focus on that chip. And maybe we can go under a microscope to make it look interesting. See what the flux is doing. And the flux isn't doing very much. It's just kind of sitting there. I'm waiting for the pins to start showing glossy like texture. And as soon as they do, I know it's time to get this thing removed. Don't want to focus on it just yet. Maybe move around a little bit more. Almost there. I can start seeing a little bit of glossy texture forming on the pins. Almost there. There we go. Right there. So now let's orient the new chip. The new chip is there. Let's throw in some more flux. Let it boil away. And drop that chip in. And I already have solder on the chip, but I did not add solder on the board. And the solder on the chip is leaded. And so we're now going to be mixing two types of solder. which will effectively lower the soldering temperature, give us a better result. We just need to be able to mix it all up like this. Just gonna move things around. Heat like this. There we go. Wait for that chip to kind of grab onto itself. Oh, looks like we might have moved that capacitor. Let's put it back where it belongs. There. Let's wait for things to cool down. Just a little bit. Press down. There we have it. Another cool down. Okay. Now let's work the pins around the chip while everything is still hot. There we go. I think that looks good. And now comes the beauty part of that flux, that we can remove it. Let me get that shield off out of the way. That we can clean most of it off without needing to bring in any alcohol. See, like that. Look at this. It's just coming right off. Almost perfect. Not perfect, but almost perfect. So, I'll finish it off with alcohol when it cools down. Alright, let's check for short. No more short. Okay. We can check for short on 5 because it is connected to the driver MOSFET. No short there. Let's power the board. See what we get. And we could even have issues with TDP or clock. A lot of times problems like these blown MOSFETs cause issues with power. So I can only imagine how many of them get repaired by this other place that end up having an issue with the clock and you won't even know it. There we go. Okay, let's see, we need some kind of a thermal compound here. So we won't know if we have a problem with the power delivery until we install drivers. So hopefully the card boots. And if it does, we're gonna have to wait for the drivers to install, and only then we'll know. So I'm gonna go ahead and skip to that part where drivers already installed, and the fact that we're getting a picture is already good news. Okay, drivers picked up. Let's look at the GPUZ and let's see if we can run FurMark real quick without overheating anything. 30% TDP. Clock is at the top. Drops down, that's good. 12.3, 12.3, 12.2. I think everything should work just fine. We're going to run FurMark for just a second to see what the TDP is doing. Nice. Okay, so the TDP went up. And I think we have a fix. Let's turn this thing off and reapply. Finally do the reassembly and all that thermal pads and stuff. Alright, the card is fixed. Now let's redo the thermal interface of this card. First, we probably want to completely forgot I have to clean all this up. So I'm going to be cleaning this off just by scraping it away and then wiping it off with alcohol, with a cotton ball of alcohol. So it looks something like this. Though a lot of times when you're getting these EVGA cards, I don't know if they're doing this from the factory or what, but there seems to be like a little bumpy metal stuff, almost like metal shavings embedded into the heatsink. I see this a lot. I don't know why it's there. Let me see if I can point you at them. Yeah, right there. I don't know what this is. It does not look like it's thermal paste. It looks like it's pieces of metal. Yeah, it's definitely metallic. So you can take a razor blade and scrape those off carefully. I don't know why they're there, but they're there. So a little bit of paste there. So we're gonna wipe this off. That's done. So that's done. Let's do some pads. As I've said before, we're gonna need 1mm for the coils. Whatever pads you like to put on there. What you want to do is you want to measure them before you put them in. Make sure that they are at least within, at least a little bit over than 1mm, 110, 115, probably okay. 125, it's going to be bad. And anything over 120 is going to be bad. Anything under 1mm is going to be bad as well. So if it's 1mm, if it's between 1 and 115, you're probably good. Also, when you're measuring the pads, using a caliper like this probably isn't good enough, because a lot of times what happens is you end up squeezing the pad too much and you're getting a false reading. So let's, for example, let's take this pad here and let's take a regular caliper that I have here that I have not upgraded. And so let's switch to millimeters here. So let's say we got 0 here, right? So 0. So if I measure this pad, so this is supposed to be 1mm, but if I squeeze it, I'm reading like 0.87. So especially if I do this on the edge like this, I could get as low as I wanted to. The harder I press, the lower the value I get. And so for that reason, I ended up 3D printing these jaws. And I don't know if I have them in my thingiverse or not. Probably not. But it gives me a flat surface, and it prevents that very thing that I was talking about. It prevents me from squeezing these pads harder than I should. So let me go ahead and cut a slice of that. So what that gives me, it gives me the most accurate reading I can possibly get. So 1.15, like I said, we're within that allowable range. They're going to squeeze a little bit, so that's perfect. Some pads are very, very hard, and they will not squeeze. So those pads are generally bad unless the tolerances are exact. And that's very difficult to achieve. So especially with these cards here, not gonna happen. So we want to have a little bit of room, or wiggle room as you want to call it. Okay, let's cut off one more strip for the left side. So that's 1mm. And all of that is assuming that the board is perfectly straight and that the heatsink is perfectly straight as well. If there's any flex, any bend, then these tolerances will not work, and you will have to manually figure out the size of the pads that you need. 1mm is done. Let's put 2 and 5 or 2.65 as I have noted here. Basically all I did, I took 2mm and 0.5mm pad, combined them together, and it gave me 2.65, which is perfect. So I'm going to cut a few strips of that. Hopefully that'll be enough. Let's put one here, like that, and one here. Cut that off. There, right there. So we're done here. By the way, we can verify the thickness of that pad. 2.54, perfect. Some areas are 2.6, some areas are 2.5. There's a little bit of wiggle room there. Exactly what you want. And next we're going to do the memory. Memory is going to be 2mm. 2mm pad. And the reason why I know this is 2mm is because the because the area that heats, that cools the core and the memory are on the same plane, and that plane just happens to be, and the height between the top of the die, between the top of the memory chips, just happen to be 2 millimeters. So that's exactly what we're going to be using here. I mean, it's not exactly 2 millimeters, but it's a little bit, it's somewhere there. So 215, 215, 214, 210, 28, with a little bit of squeeze. And once it all assembled, it'll compress it even further, all the way down to 2, and that should be okay. If you're doing this, make sure that your fingers are at the very least dry and not greasy. So generally speaking, I'm very dry, so I don't have to worry about wearing gloves when I do this. But if you're sweaty, you got sweaty fingers, put some gloves on. It will help with preventing your sweat landing on them chips, causing issues. Or at least not so much issues, but to affect the cooling performance by about 0.05%. So if that doesn't bother you, who cares? Clean up the core with the swab. Make sure it looks nice and dry. Make sure that there are no fluffs left from the swab. Apply paste in this fashion. There's no need to go crazy with spatulas, spreading it out, creating some sort of weird patterns. This will do. Generally speaking, most of these graphics cards just an X and you're good to go, and it will look exactly like a factory application. So trust me on this. I've done this enough times to know what I'm talking about. So let's put this over here. Make sure nothing's gonna fall off when you flip it over. If anything falls off, just kind of run your finger over it, press it down a bit so it doesn't fall, but nothing falls out. So let's connect this little cable here. That's for the LEDs. Just gonna grab it there, connect it like so. Then we're gonna connect these fans. 1, 2, and 3. Remember that wire kind of goes under the heatsink a little bit, so it's tucked out of the way. Then we're gonna align this hole here. This pin that you can see here and the hole on the board, they can actually align. So you align that, and then right there. Now you align the holes for the leaf spring. So we're gonna start with 1 screw, maybe 1.5 turn, then go on the opposite end, maybe 1.5. And I'm helping to push the leaf spring with the finger as well as with the screwdriver at the same time, just to make it easier. And then we'll finish it off with the remaining of the 1.5 turn, or whatever, however many turns I've left. Right there. So there we go. We can already have a look and see and verify visually that all of the pads are contacting the core. The board, as you can see here, there's perfect contact with the driver MOSFETs, with the coil, with the memory chips on both ends of the board. Now the issue with the EVGA, particularly with this design of the board, is that, or the cooler rather, is that there's nothing connecting the board and the cooler on this end, so there's nothing really squeezes them together. So if for any reason there's any kind of separation, it's very likely to happen because there's nothing that's really squeezing these two together. There's plenty. There's the two mount holes here that will connect the two, force the two halves together here and then on this end, but not on this end. I don't know what these engineers were smoking when they were designing this thing. There should definitely be some kind of a thing here. I mean, there are holes here. All they have to do is to extend a piece of aluminum or something so that the board is actually squeezed all the way across. But they didn't do it. Probably ran out of pot or ideas. Who cares? Doesn't matter. I don't care. Not my problem anyway. And the EVGA is dead, so who cares? Apply 2 millimeter on the back as well. And this one's going to be a little bit tricky because the backplate is oftentimes can be bent by you trying to remove it, as I was explaining earlier. And so You could potentially run into issues where the backplate does not contact the memory chips very well, and so that would make your memory run a little bit hotter than you would want. And there'll be nothing you can do about that, except I'm going to show you what you can do. So here you can use bigger pads, not like the ones that were here from the factory. Those were a little bit narrow, but we were using a little bit wider pads to spread the contact, to help, you know, with the heat transfer and whatnot. So let me show you what could be done in the event of the backplate not being, you know, perfectly flat. Sometimes it gets a little bit curved and whatnot. It makes it worse. The fact that we don't have any kind of retention on this end of the board with the heatsink just makes this problem so much worse. And there's really nothing you can do. And then the remedies that I'm going to suggest to you could potentially be counterintuitive, because they will apply counter pull force, so they're going to try to pull the board out, effectively separating this end. But that had never been a problem, so I still feel confident suggesting that fix. So basically what I was going to suggest is, with these screws here and some on the back, doesn't matter, but no screws here at the front, just kind of close it, keep it all together, sandwich together, and look inside, and look inside here, inside there, and flip it over, look inside there, and just kind of make sure that you can see that all of the chips, all the memory chips and the backplate are contacting. And if they don't, what you want to do is to just kind of pull a little bit on that board, on that backplate, just a little bit, creating a minor flex. As you can see here, see there's a little bit of flex, and that might just be enough to apply a little bit of tension because of the curve that you've created now, and squeeze those chips a little bit closer. Like, I can definitely see that the chips that are on this end are not contacting, they're not pressing very well. So what I'm going to do is I will, since I have good contact here, I have no reason to create any kind of shapes in here. So what I'm going to do is I'm just going to do this a little bit and then kind of see. Oh, there you go. That just stuck perfect. Yeah. So that'll work. So that created a little bit of a curve, pushing this end a little bit toward the chip better, effectively fixing the inherited problem of the EVGA's cooling solution. I don't know why they designed it this way, and I don't really care. So let's continue with the assembly. The nut here can be held just by the finger, but the one that's over here, we're gonna need some kind of tweezers, or you can try needle nose pliers. I'm just gonna use these tweezers. Hopefully I can get in there without dropping it in. Even if you drop it in, it's okay. You can fish it out. Just, it'll fall right out, and it's not gonna get stuck, so don't worry about it too much. And we got one more nut here in this corner on the bottom. And one more screw. And that will be it. So we're done servicing this GPU. I'm going to go ahead and test it out. You'll see all the temperatures and everything. So if you find this video helpful, please consider liking, subscribing for more repairs. And hopefully I'll see you later. Goodbye.